Thousands of induction unit systems are still operating in office buildings today. Unfortunately, some building automation systems, BAS, retrofits, unknowingly increase energy consumption instead of reducing it. In this video, we'll examine how these systems work, identify two costly programming errors we encountered in the field, and explain how proper control logic can avoid these mistakes. Induction units were widely installed in office buildings and high-rise facilities during the late part of the 20th century. Many of these systems are still in operation today. Although they are considered advanced for their time, induction unit systems are inherently inefficient. Their design causes simultaneous heating and cooling within the same unit, resulting in unnecessary energy consumption. This drawing illustrates a typical induction unit system. The primary air supplied to the building is a mixture of outdoor air and return air. During the winter, the primary air provides cooling function for the induction units. During the summer, when outdoor conditions permit, the same primary air provides heating while operating in economizer mode. Primary air is delivered to each induction unit at a relatively high pressure. It passes through the nozzles or the jets. It creates a low-pressure area that draws room air through the coil. This process is known as air induction, and it allows a relatively small amount of primary air to regulate a larger volume of room air. The room thermostat, either mounted on the wall or built into the induction unit, controls the valve and serves two different purposes. In the winter, it regulates heating water, while in the summer, it controls chilled water. This dual-purpose operation is made possible by a seasonal control pressure change that switches the controller from direct acting in winter to reverse acting in summer when using a normally open valve. The exact changeover pressure varies from manufacturers and sometimes even between different product lines from the same manufacturer. For this reason, verifying the correct changeover point is essential whenever replacing or upgrading induction unit controls. Two major BAS retrofit errors. Economizer changeovers number one. A building owner asked us to evaluate a newly installed building automation system, BAS. One of the major problems involved the economizer circuit. In the summer operation, when the outdoor temperature is approximately 10 degrees Celsius, the primary air is normally reset to about 32 degrees Celsius. However, the BAS did not switch the main air mixing dampers into the economizer mode until the outdoor temperature reached 21 degrees Celsius. As a result, the system had to add approximately 11 Celsius degrees more heat to reach the 32 degrees Celsius primary air set point than it would have been if the economizer had been enabled immediately when the system changed to summer mode. This unnecessary heating represented a significant energy waste. Error number two, incorrect primary air reset. In another building, a newly installed BAS reset the primary air temperature to increase continuously as outdoor temperature dropped from 20 degrees Celsius to minus 23 degrees Celsius, while hot water remained available to the induction units operating in the winter mode. This control strategy was fundamentally incorrect. Unlike the first example where the excessive energy might have remained unnoticed, this programming error caused the entire system to become non-functional and required immediate correction. An important lesson. The excessive energy consumption in these first buildings may have never been discovered had the experienced building operator not questioned the BAS programming. When the BAS installer dismissed the concern, our company was asked to investigate. We found numerous additional programming errors beyond the economizer issue. The second building was less fortunate. The programming error was so severe that the system simply could not have operated properly. A simple rule for evaluating control logic. A good control system should make the same decisions that a knowledgeable building operator would make operating the system manually. If the BAS is positioning valves, dampers, and other control components in a way that an experienced operator would immediately recognize as illogical, there is very likely something wrong with the control strategy. Computerized control systems do not guarantee energy efficiency. A BAS simply executes logic it is given. If the logic is flawed, the computer will faithfully waste energy every hour of every day. Good HVA control begins with good sound logic, not sophisticated software. Conservation logic coordinating the heating, cooling, and ventilation in induction systems can significantly reduce the energy consumption. On our website, apscontrols.org, there's an article titled Fighting Climate Worry. Within that article, are links to two reports that are highly significant when considering the future of today's children. The first is a BBC report indicating that more than 50% of children are regularly worried about climate change. The second is a Stanford University report projecting that the world could exhaust its economically recoverable fossil fuel resources within the lifetime of the children living today. These findings underscore the importance of taking climate change challenges seriously and pursuing practical, effective solutions. Just as importantly, we need to demonstrate that meaningful action is being taken, helping to reduce the anxiety many young people feel about the future. With respect to controls logic and energy conservation, it is important to understand that no solution can be applied everywhere. What we are really teaching is comparable to teaching someone how to play chess. We can show you the moves and strategies that have been proven successful in addressing conservation challenges in the past, but we cannot predict every situation you will encounter in the future. For that reason, I encourage you not to simply memorize the concepts presented in the APS training manual. Instead, strive to understand them deeply. A thorough understanding transforms information into a practical tool that can be applied to new and unforeseen challenges. As Albert Einstein famously observed, information is not knowledge. Information alone has limited value. Knowledge is gained when information is understood and can be applied effectively in the real world. Thank you very much for your efforts with respect to climate change, and I believe that collectively, with everybody trying, we can make a major impact on the threat to the children's future.